Let's write an equation for the reaction between iron 3 chloride and sodium hydroxide solutions. Let's start with what we know. Iron 3 chloride is made up of iron 3 plus cations and chloride anions, which have a 1 negative charge. We can crisscross these numbers on the charges to get the ratio to determine the formula unit for iron 3 chloride. So the formula is FeCl3. And these are both in aqueous solutions, so we'll put that in parentheses, AQ. Leave a little space for the coefficients. And sodium hydroxide is NaOH. It's a strong base, completely dissociates in water. So at this point, you should recognize this is a double replacement reaction, sometimes called a double displacement reaction. We have two compounds dissolved in water made up of cations and anions. So what's going to happen is the cations and anions are going to swap partners. Therefore, we can predict the products. Iron is going to be with hydroxide, and because of the charges, we know it's a 3 hydroxide to 1 iron cation ratio. So we'll need parentheses around the hydroxide. Now, hydroxides are generally insoluble, so this is going to be your precipitate. Now, we'll learn this as we go through the chapter when we get to solubility rules, which will be on your reference sheet on your test. And the other species is going to be sodium, now being with chloride. And you know this is just a 1-to-1 ratio. That's table salt. And that's highly soluble. So this is going to remain dissolved in water. Now let's balance the equation. We'll separate the reactants from the products. On the reactant side, I see 1 iron, 3 chlorides, 1 sodium. I'm going to keep the polyatomic ions together because you can see before and after the hydroxide is unchanged, and there's 1 hydroxide. If you write the O and the H on separate lines, it's just going to be a mess oftentimes. So over to the right side, the product side, I'm going to put them in the same order so it's easier to compare side by side. And on the product side, I have 1 iron, 1 chlorine, 1 sodium, and 3 hydroxides. So I can see the balancing needs to be done with the chlorine and the hydroxide. So it's not going to matter which one you start with first. I'll just do the chlorine. I'm going to go to the product side because I need to multiply that to balance out with the 3 chlorines on the reactant side. So that multiplier needs to go where I see the compound with chlorine. All right? I can't squeeze coefficients in between formulas. So I need to put a 3 in front of the sodium chloride. And by doing that, I also need to multiply the sodium by 3. I need to distribute that coefficient to all the elements in the compound. Now I'm going to go over to the left side and rebalance my sodium. Put a 3 there, and that's going to end up balancing everything else I need. So the balance equation, and you can put these ones if you want for this chapter, but we normally don't write ones. So here's your balanced equation for the double replacement reaction between iron 3 chloride and sodium hydroxide.